Okay, so the online results should be ready. So let's see the online results for Arrow and CW, right?
Yeah.
Arrow and CW, VI, ls minus, ls minus LRT start.txt. Okay, now we see two new files, cw drebin.txt and cw, for metadata as well, and on Arrow metadata as well. Okay, now, okay, with confidence weighted, we see the number, over 90, and also the features are different, but it's not as high as online perceptron.
Yeah.
So we see, a very high accuracy on the test set, but it's not 98, it's 94. So we assume that there is some regularization for confidence weighted as well. Okay, so yes, we are seeing different features, not and each of them makes some sense because they are having runtime exec, send SMS, add mob activity is something which is meaningless, but still it finds a place on the top list. Others seem to be okay, so this is kind of overfitting for me. Seems like okay. This is from where? Only the training, right?
Yes.
But how do you make sure? Because let me see. You're saying top features only, but it doesn't say that whether this is from the whole data set. This seems whole data set. Test set accuracy and this one, but the top features is from whole data set or the training set only. Can you check the code? Only then, no, from here, so that we can see this one. There are two different places where you print top features. Can you check both of them?
Yeah, this is the first time. This is the first time reading that.
Yes. So this one will give you the new line vectorizer, which is already fitted on. No. You need to. The vocab is fine, but you need to check the weight vector that is being used. Feature importances comes from model. So the model at this point is fitted with both training and the test set. Right? From this is in which line? Can you just print the line number as well? Alright, so this one uh, happens. Yes, I want to see how many times this one happens. This one happens in line 252 only, and this one happens after the training set is fixed, the test set is fitted, right? But why do we see two times? I'm not able to make sense of the flow. I need your help in understanding this. This is all clean, this is all like pre-processing, yeah, fine. And then here is the first time you fit your new line vectorizer, right? And then this is on the training set, and then you transform the test set to that particular vectorization, and then you do TF-IDF, that's all fine. And then you perform classification for batch, right?
Yeah.
So the batch will give you the best combination. Okay, but why? Okay, best model you are again fitting, right? Where are you choosing the best model? See, what is the ratio for the cross validation. What
Can
is best model?
you
Let
go
me
up?
check.
Up.
Okay, best model SVM is going to do all this. CV equals 5. Parameter grid is this. Max iteration is this. But what is the size of the validation set? Is it default size? Right?
Yeah.
Okay, I think it's 90-10 or 80-20. Okay, in that case it will be only fitted with 80% samples or 90% samples, depending upon what's the size of the training set and the validation set. Anyways, that is also still okay. Okay, so we have this SVM best model, PA best model, perceptron best model, SGD best model, and then we go inside this loop. I think we print it for every model.
Yes.
Right?
Yes.
Okay, that is what we are seeing. Then we should see it only once inside every model's txt file, right?
Yeah.
But why do we see it 2 times inside?
The second time actually is the with vector multiply with is average with vector.
The first one is the classifier's best, and the second one that we are seeing is the test set's average weight vector.
Yeah.
Oh my god, so far we have been totally misinterpreting, and all the recording that we have done so far is kind of misleading, right? So the important point to understand here is there will be 2 prints inside every txt file.
Yes.
For SVM there will be 2 prints, for SGD there will be 2 prints, for PA there will be 2 prints, and for OP also there will be 2 prints.
Yes.
And each of those print is different. They are not on the training and the test set. The first one is the best features for the classifier as a whole, and the second one is the average weight vector of the test samples multiplied by the weight vector that is completely fitted on both training and the test set.
Yes.
Okay, so where is the evidence for that? So I think this is the first place where we see the
Yes.
print,
Yes.
and this should be 100.
Yeah.
And in this is the second print, right?
No, this is not the second.
This is what?
This is
Certain parameters for certain models you will have the
Yes.
coefficient, for example SVM,
yeah.
and for certain other things you will only have the model of mu, which is
Actually,
this is not here, right?
Initially, I would like to combine all the
Okay, scalar and not scalar also.
Yeah.
So this one portion is for the not scalar.
Yes.
Okay, so where is the second print? Okay, this is the average FE of day.
Yeah.
That means average FE of the whole test set.
Yeah.
So you are taking a mean on the x-axis, and then you are converting it into a dense array, and then you are multiplying. Where are you multiplying? No, this is average weight vector. That's okay. See, average vector of all the test samples, right? No, not this. What is this feature importances of sparse array? So this is the test set, right?
Yes.
We are first initializing an array, a sparse array,
Yes.
and then we are setting the diagonal of this to the feature importances.
Yes.
All feature vectors times W is the test feature vectors times this array. What is test feature vectors? This is here. I don't know what's happening, but anyways, I hope this is right. Okay,
This is
so
removing all the negative samples from the test.
oh, okay, from here you are actually removing all the negative samples, is it?
Yes.
Before deleting rows tests. Okay, so now the test vectors only refer to the malware in the test set, and then we multiply the malware with the feature importances, right? All the malware features with the feature importances here in line 278, right? And then we take the mean of that, and we take the first 100 top ranking features according to the weight as well as the feature importances. And then we get the name of that feature from the vocab and print it. That's all. Right, so let's go to the temporal trend now. And we are done, right? We need to see something. Okay, we need to see the files. Yeah, CW we saw. Okay, so I think you can add some more meaningful prints here rather than, like, what you can say is this is classified top features. That's very important, not just top features. What I expect is at least in capital classifier top features, because I'll be totally lost when you're gone, when I don't see this video. This file is not very informative. Okay, so here, this one, and yeah, here, this is average. Somewhere at the end of this line you can say average. Okay, something like this. Average positive sample from test set times weight vector. Something like this. So this will tell me that this is fitted on the test set. And 100 features each, right? Okay, so likewise we will have arrow. Come on, this is poor compared to even the batch learner gets a better accuracy. I think arrow is kind of, I don't know what is that to explain. I need to learn the literature, only then I can explain this result. Do you have any idea? You want to add any points here?
Actually, arrow but for random speed classification, arrow does not give this worst performance.
Only when you hold out, arrow gives the worst performance.
Maybe it takes more maybe it tends to stay stable of this weight vector.
And doesn't change much.
Yeah, if the feature, various features are quite different from GB, it tends to remain stable. And
what is the learning rate? I think you will print that as well. 0.01. Yeah. So this is what best parameter?
This is the C
margin.
Yeah.
Okay, so we need to see the top features for the average weight vector. This is for the classifier, right? Restart packages, SMS email, boot completed, secret code, WANA data. All this seems to be sensitive permissions and all that. Yeah. So here we see send message, get package info. Actually, it has changed, right? Restart packages has moved device ID restart packages right externals to it, and it's changed, but I don't know what is the significance of this from the classification point of view. You only take the top features for the negative or so the positive samples, so I don't know how the influence actually changed. Okay, so let's see the arrow for exp1, then we can see, right? It got 99%. Yeah, it was restart SMS, something like this. And once it has been fitted for the test set as well, it was receive SMS boot completed, get ISO SMS. So something is happening, but it fits, and the training and the testing are from the same distribution. Okay, I will see whether I need to include this or just go ahead with CW, because I'm okay with CW. Arrow I cannot explain. Okay, let's see the last one, and then we will conclude for the day. Yeah, XP4.
Actually, I have already run the whole.
Okay, then we just see the result and we finish off. ls minus lit start.txt. What is temporal trend? First, tell me that overview.
It will take for 30% of the training set based on the timestamp at the training set. Maybe 70% at the training set, and the rest of the 30% to be the testing set. Yeah.
And then it will. Why is the 70-30? We can change it, or
yes,
we can.
This
Command by. Okay, so we can have certain percentage of the first time stamp.
Yeah.
Samples for training, and okay, you can split the training and the test set inside the same data set, not necessarily
Yes.
like virus share and Drebin.
Yes.
Inside the Drebin also you can put a timestamp for each of the samples, and then you can control the classifier to be built or trained only on the first few
Yes.
timestamped
Yes.
samples. Likewise for the benign also, and then you can fit the remaining as a test set.
Yes.
And where the SVM will fail, and then the PASGD will get the advantage,
Yeah.
since they're online learners.
Yes.
That's what we are going to see now.
Yes.
Okay. Let's see the SVM. Oh, can you just show the one more running as well? Can you run the code one more time as well? Because this seems to have the command line parameter to choose the training and the test set size, right? So we only run the sklearn version. That's okay.
How will we run this?
Yeah.
Okay.
Then this is similar to the exp1, right?
Yes.
Because there will be only one training and one test set.
Yes.
Yeah. Online benign. This is what?
This is the sleep, which means we use the last 30% as the test sample.
It will take a long time, right?
This should take around 2 or 3 minutes.
So we keep recording. Still okay? Pause. Okay, now the results are ready for arrow and CW. And first let's see SVM. Temporal trend, first 70% of driven
Yes.
as training, and last 30% as testing. Okay, so SVM is having 0.01 C and the other parameters, and then you have 75% F measure for malware, which recall seem to be 1 and precision takes a hit. Why? Because whenever it sees an old malware, it's able to identify, and whenever it sees a new malware, it's not able to identify. That's why the precision takes a hit.
Yeah.
And recall, actually in that case precision should be 100% and recall should be less, right? Because new malware cannot be identified, so which means there will be false negatives.
Yeah.
Right? And there will be no false positives.
No false positives.
There will be only false negatives.
Yeah.
So it should affect only the recall and not the precision.
Yeah, but
Okay, so we have false negatives. We expect a large number of false negatives, right?
yeah.
Because it can only identify whatever it has seen and it cannot generalize. Like, let's say there is one family of malware which sends SMS, so that particular family it can identify. If a new family of malware comes in the test set, the 30% of the test set, and it doesn't, it actually has new functionality, let us say, some internet privacy leakage, so it is not related to its SMS. So whatever characteristic it learned for, it is not going to match with the new malware, so it's going to classify the new malware as a
No.
benign one.
Yeah.
So it's going to mark it as a false negative. That's a false negative.
Yes.
Right? It is going to say it is negative, but it's false, so it's false negative. So the denominator of this quantity is going to be high. So which means the recall is going to be close to 0 and not close to 1. But what we see here is the recall is exactly 1. Probably it is a problem with the training set and the test set, because you are not subjecting the full Drebin. You are not fitting the classifier on the full Drebin, it's just a few hundred samples.
Yes. Mostly this the they are
Mostly? Yeah.
mostly they are within the same family.
Okay, so you have 200 test set samples and 700. Is it 700? Yeah, right. 700 test training set samples and 200 test set samples it should be. And this one is what? This one is a classified top features.
Yes.
And this one is the average positive vector top features from the test set, right?
Mm-hmm.
Yeah, this one is average FE times W. Alright, so likewise we will have, let's open the PA, right? 98%. Alright, no, nothing more to see. Okay, let's see the precision recall. I mean, anyways, it's all about 98, right? Okay, let's see. Perceptron 99. Precision is 1, recall is 98. How about for the other one? Precision is 98, recall is 99. Let's see. SGT 98, 98, 98. Let's see CW. I have a question here. How do you make this one as underscore Drebin? Because you say it uses Drebin features.
Yes.
That depends on the command line argument with which you call the classifier. Like for example, if you see this one to be data.txt, you put underscore Drebin here. And if you see WL2, then you put WL2 here.
Yes.
WL here. Okay. But anyways, that can be tuned from your code, right? It should be straightforward. Okay, so we saw 98 for CW. Let's see arrow. $99, $98. Alright, so that's the end of it, right? Do we need to see anything else for the temporal trend?
No.
Let's try this. Let's actually try to fit it on. Maybe we give this one. We first use only the 5% for SVM. 95% testing.
Okay.
That should really confuse SVM, and its precision should be damn low, and it should have a high recall. I mean, at least a decent recall. Right? Here, what we are trying to say is use first 5% for training and remaining 95% for testing. And not SK1 should be removed. Right?
Yes.
Because SVM.
Yes.
SVM and right?
Yeah.
Can you only use SVM? Can you only do SVM and then stop? Cannot. Yes, you can see the training set is only 38 and the test set is 747. That should be really quite a challenge for SVM, right?
Yeah.
But for online, it should be still okay.
It's done.
Done.
Yeah, because training set is very small, so.
So for all other classifiers, I mean, what I mean is like for OP, for SGD, for PA.
Yeah.
They're all done.
Yes. Since it takes very little time to go through all the
parameter search, right?
Yes.
The parameter search is so fast. And that is leading to. Yes. Let me try again. At least there will be some colors. Nothing. Okay. Yeah, okay. This time the precision seems to be 98 and recall seems to be 93. And see. Okay, let me see. Yeah. 98, 95. Almost same for PA as well, but actually PA should show the other way around. We should have high recall as well as high precision. Let's check its PD. Yeah, it's quite okay. Let's check our Perceptron, which is a surprising package all the time. Okay. So this one, what I observe here is like we need to even force it very critically. Yeah, 15 samples only, and then SVM should actually try to fumble But I'm really surprised why SVM still gets more than 90% right. 700 samples, do they really resemble these 15 samples? I really doubt it. The 15 samples is representative of the 770 samples. My god, how am I going to explain this? 65% precision, 1 recall. Something is happening. It is absolutely identifying all the test samples correctly in terms of false negatives. It doesn't have one false negative at all.
Mean false negative.
It has a lot of false positives. That's why the precision is 65%.
Yeah, that I think that may be because I mainly use fake installer for this
Fake installer
for this small training set as malware.
So there is only one family.
Almost malware.
Alright, so that means from one family, if you learn the characteristics, then you have very less chance of getting false negatives.
Yes.
What's the time now? 6:50.
650.
Okay, I need to very quickly wrap up, so let's see the plot. Okay.
So this is plot for experiment tree.
Can you just move this so the light one is coming? Yeah. Yeah, can you make the full image visible? Because there is legend. No. Can you just make it little, the minus here, bottom here. Minus, right? Minus, one more minus. Yeah. Okay, now we have the plot for EXP3,
Yes.
right? Where we fitted the classifier on the Drebin and tested the classifier on the test set. So we actually taxed the batch learners too much because the bioshare is 2 years older to Drebin.
Yes.
I mean 2 years younger to Drebin. So
yes.
Drebin is like very old, and then it will have certain characteristics that are not reflective of the bioshare samples. So we expect SVM to perform poorly. So we see the best classifier to be CW, and the next best to be perceptron. Both are online, and they have nearly 1% error, like less than 1% error, right?
Yes.
Yeah, and then we also see SGD performing quite well, and PA performing